All right, welcome back, physics friends. Today we're going to walk through a problem that if you're in AP Physics or perhaps intensified physics, it would be really useful for you. But maybe regular, it depends on how in-depth your physics teacher gets into it. But this is an interesting problem. I call it how much more force? So I have this box, has a mass of 10 kilograms, and it's sitting on an incline of an angle of 75 degrees. So it's super steep. And so it will move when you put the box on the incline. So the kinetic friction coefficient is 0.32. And I'm curious, how much additional force must we apply on the box perpendicular so that the block will stay at rest? So I'm asking, how much more force do I need to apply in this direction to hold the block still? That's what I'm looking at. Okay, so that's interesting because what that tells me is that the net force in the x direction must equal 0 because it's going to remain at rest. Because in the x direction, I want F net equals ma, acceleration to be 0, so I want the net force to equal 0. Okay, well, that's not that big of a deal. That means that Fgx, the downward force here, the helping force, and the frictional force have to be equal to each other. That's what that tells me. This in the x direction tells me that Fgx must equal the force of friction. Otherwise, it would move. Okay, so how do I find Fgx? Well, again, here's my angle theta, and that's the opposite side. So that would be Fg sine theta. Now, if you don't know where I'm getting that from, you might want to go back and look at the intro video. I go over how we find Fgx and Fgy. So this is mg sine theta equals mu Fn. Oh, okay, well, what's Fn equal to in this case? Fn is, so if we look at the perpendicular parts to the incline, I have Fn pointed up and I have Fgy pointed down, but they're not equal to each other. Because if I'm keeping this block at rest, I also have another force pointed into the incline. So if I make this a little bit bigger and I just look at the forces that are perpendicular to the surface. So here's your Fn, which is what I need to know to figure out what friction is. Here's my Fgy component. But then I also have this other downward force pushing on the block, that other pink arrow. So I have another force, F, right here. So that tells me that the normal force, because it's at rest in this direction, the y direction, Fn must equal the sum of Fgy and this other force F. So Fn equals Fgy plus Fn. And I can take this and I can plug it in right there. So now I get mg sine theta is equal to mu, parentheses, Fgy, which is mg cos theta, plus F, this other F force. And that's what I want. How much additional force? This is my variable that I want to solve for. Okay, so that's cool. I have everything else, so I can simplify. Essentially, I can divide by mu and then subtract the mg cos theta to the other side. The other way you could do it is you could distribute mu within the parentheses and then subtract and then again divide. Doesn't matter. Either way, you're going to come up with the same answer. So I'm going to go with mg sine theta divided by mu, then minus mg cos theta equals F. Okay. And so now when we plug in, we have 10 kilograms, 9.8, sine of 75, all over 0.32, minus 10, 9.8, cos of 75 equals F. And so this first term, when you do the math, I get 295.8. And the second term, I get 25.4. So that equals F, which is 270.4 newtons. So you would have to push on that block perpendicular to the surface with 270.4 newtons or more to hold it in place. And you can do this problem in other ways, like how much more force pointed up the incline would you need in order to hold it in place. There's lots of variations of this problem, but that's a really good one to know how to do. All right, so I hope you enjoyed it, and I'll see you in the next video.